Welcome back to mathematics class with Ojobo Hyginus. Stay tuned and enjoy the class.
In continuation from our previous class where we did conversion of decimal number base to base 10, we are going to now look at conversion of fractions of decimal numbers in base 10 to base 2. So look at this question. You are asked to convert 9 whole numbers 7/8 base 10 to base 2. I will do that in two different methods. Solution: you convert 9 whole numbers 7/8 base 10 to base 2. What we'll do is that we are going to convert the whole number differently and the fraction part differently. So for the whole number part, we have 9 base 10 to base 2. What do? We the same way we've been converting. So you divide it all through by 2. So you have 9 divided by 2. To divide 9, you have 4, remainder 1. To divide 4, you have 2, remainder 0, because there won't be any remainder. To divide 2, you have 1, remainder 0. And then to divide 1, because 2 is greater than 1, you have 0, remainder 1. You read from bottom to top. That will give us 1001 in base 2 from base 10. We've converted the whole number part. Then let's look at the fraction part of the number. That is 7/8. 7/8. 7/8 in base 10 to base 2. Now this is the method we use. For the first method, what we will do is that since 8 is a multiple of 2, of course the denominator has to be a multiple of the base you are converting it to. And then the numerator, we are going to split it to multiples of 2 as well, starting with the highest possible multiple of 2 that is equal to or less than the digit you have at the numerator. What do I mean? Since 7 is at our numerator, we have multiples of 2, 2, 4, 6, 8. We have 2, 4, 8, 16, 32. So we are going to use, so 7/8 will be 0.875 base 10. So how do we use this method? We'll say 0.875, multiply it by the base you are converting to. We are converting to base 2. So we'll say times 2. 0.875 times 2 will give us 1.75. We take the whole number part, that is 1, then multiply the remaining part, 0.75. If you remove 1 from here, it will be 0.75. Multiply it again by the base 2, that will give us 1.5. You take the whole number part as well, then the decimal part is 0.5. Multiply it again by the base 2, and that will give us 1.0. You take the whole number part. That is how you'll be doing it until the decimal part is 0. And since we have gotten 0 here, we stop. And then we have 1, 1, 1. This one is read from top to down. The other one, in the case of whole number part, is a conversion, is read from bottom to top. So this is 1, 1, 1, and that is that 7/8 base 10 is equal to 111 base 0.111 base 2. So 9 whole number 7/8 will be equal to, in base 10, will be equal to 9. We got 9 as 1001, then 0.111 base 2. So whichever method you prefer will give you the same result. To solve one more example using the two methods we've learned, convert 25.5625 base 10 to base 2. The first method, we have 25 0.5625 base 10, the first thing we are going to do is separate them. This is going to be 25 plus 0.5625 in base 10. Then we convert them differently. If we convert 25 base 10, remember, to base 2, that is going to be divide 25 through by 2. You say 2 divided 25 will give us 12, remainder 1. 2 divided 12 will give us 6, remainder 0. 2 divided 6 will give us 3, remainder 0. 2 divided 3 will give us 1, remainder 1. And 2 divided 1 will give 0, remainder 1. You read from bottom to top, that is going to be equal to 11001 in base 2. That is the whole number part of the number. So we look at the decimal part, which is 0.5625 base 10. The first method, what we have to do is to convert to fraction, and to convert this to 0.5625 to fraction is going to be 5625 divided by, you have how many digits after the decimal point? 1 2 3 4. So we are going to have 1 0 0 0 0, 4 zeros. So that is it in fraction, and then we'll reduce it to its lowest form. Reduce it to its lowest form. So if you reduce 5625 over 10,000 to its lowest form, will be 9 over 16. Remember, it's base 10. And then from what we've learned, that 9 over 16 base 10 can be splitted. You look for those numbers I mentioned, that is multiples of 2 that is less than 9. We have 2 times 2 4, 4 times 2 8, 8 times 2 16. So from these numbers I have mentioned, the 8 is the closest to 9, that is less than 9. So I will write 8 over 16. If I remove 8 from 9, I'll be left with 1, then 1 over 16. I have no other option than to write that one all over 16. So this is what I have. And of course, I said we'll reduce it again. If we reduce further, we'll simplify the fraction. 8 over 16 is 1 over 2 plus 1 over 16. And then in index form, you know this is 1 over 2 plus 1 over 16 is 1 over 2 raised to power 4 is 16. So if you look at this, now this is very technical. If we look at this is written as, of course, we can say 1 times 1 over 2 is 2 raised to power minus 1. Then this one is 2 raised to power minus 4. So we'll say 1 times 2 raised to power minus 4. Now, in this kind of conversion, we do not jump. So we are going to represent every position. Since we have minus 1, we should have minus 2, we should have minus 3 before we have minus 4. So, but since there is no minus 2 and 3 in what we have here, what we ought to do is to introduce it. So if we write 1 times 2 raised to power minus 1 plus, how do we place the times 2 raised to power minus 2? Since there is no minus 2 here, we are just going to multiply it by 0, because we know that 0 times anything will still be 0. So we've not actually introduced anything. So we'll do 0 times 2 raised to power minus 2. And since there is still no 2 raised to power minus 3, we'll still do the same 0 times 2 raised to power minus 3. So those ones that are not there that you have to introduce, you just multiply by 0. That is just a simple way to do that. So we have 0 times 2 raised to power minus 3. Before we'll now write the final one, 1 times 2 raised to power minus 4. And you can see that from here, if we take it back to what we have, the number here is 1. So this 0 point, we have 1 0 0 then 1. That is how you convert it. So I mean that all positions must be represented. You cannot have just -1 and -4, because there are positions in between -1 and -4, which are -2 and -3. And since they are not in this number, we just multiply it by 0. So anyone that is not represented here, that you must represent, multiply it here with 0. So that is how we've been able to convert 9/16 in base 10 in base 10 to 0.1001 in base 2. So if we put the two numbers together, it means that 25.5625 base 10 is equal to 25 will go 11001, then 9/16 will go 0.1001 in base 2. That is how we've done that. Then using the second method, remember we've gotten 25 base 10 to be equal to 11001 base 2. So the one that we are going to solve alternative method for is the decimal part. So the decimal part, which is 0.5625, we said that the alternative method is to multiply by the base you are converting it to. So we multiply this by 2, we have 1.125. You take down the whole number part and multiply the decimal part 0.125 again. You have removed this one, is 0.125 by 2. We have 0.25. You take the whole number part, that is 0, and multiply the decimal part 0.25 by 2 again. We have 0.5. You take the whole number part, that is 0, and multiply the decimal part 0.5 by 2 again. That is 1.0. And that the whole number part, you take it 1. And since the decimal part is now 0, you end there. And then read from top to bottom 1001. So we have 0.1001. Therefore, 25.5625 base 10 is equal to 11001.1001 base 2. And we are good to go. Amongst the numbers I have mentioned, 2, 4, 8, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So amongst this number, I think the one that is less than 7 and closest to 7 is 4. So I am going to have 4/8. Then after that, the next one, if you remove 4 from 7, we have 3 remaining. After that, the next number, the next multiple of 2 that is less than that 3 is going to be 2. So I have 2/8. If I remove 2 and 4 from 7, we'll be left with 1/8. You will agree with me that if I add these 3 fractions, it will give me back 7/8. Is that taken? That is it. So if we do that, this is going to be equal to, we reduce it to their lowest fraction. 4/8 is 1/2, plus 2/8 is 1/4, then 1/8. And this can be written in index form. Or first of all, let us break it down. This is 1/2 plus 1/4 is 2 raised to power 2. We agree with that. Plus 1/8 is 2 raised to power 3. And this is the index form of this fraction. And we know that 1/2 can as well be written as 2 raised to power -1. Plus, we know that 1/2 raised to power 2 can be written as 2 raised to power -2 from our indices. Plus, we know that 1/2 raised to power 3 can be written as 2 raised to power -3 from our indices. So if you look at this from what we did the origin initially in converting from base 2 to base 10, you remember how we placed this. So this, since this is -1, -2, -3 in their position as we had in our indices, of course we can actually put 1 to it. This can be written as 1 times 2 raised to the power minus 1 plus 1 times 2 raised to the power minus 2 plus 1 times 3 times 2 raised to the power minus 3. And this, from what we have here, this is the same as this, because 1 times this number will still remain what it is. So we can actually say that since this is a place value, taking a place value of minus 1, minus 2, minus 3, this is going to be 0.111 in base 2. So if the first one we converted was 1001 base 2 and this one is 0.111 base 2, if we put them together, we are going to have that 9 whole number 7/8 base 10 is equal to 1001. Then that 0.111 is 0.111 base 2. That is how we are going to do that. Then alternatively, if we use the second method, of course the second method does not affect the whole number parts, because that's the method we've used before is the method you can use to solve the whole number part. But I am talking about the fraction parts. That 7/8 can be converted first of all to decimal before we use the second method. 7/8 base 10, we'll convert it to decimal before we use this.
Thanks for watching. See you next time.